So good morning class. In the last lecture we have seen what is by collaborative filtering. Okay. So in the last lecture, we have seen if any X user is logging for any online shopping website, for example Amazon website. So we have to find some collaborative or similar user where they have some similarity. Okay, so that is called the similar function. We can find out the similar function, and according to that we are predicting the item to the user. Okay. So how to find the similar user? This is a most important part in collaborative filtering. So today we will see how to find the similar user among your data set. So let us consider this is an data set. Okay. In this data set, there is A, B, C, D are indicating the users. There are the 4 users in my data set, and I have the one movie data set, and in that movie data set, this column or feature are indicating the name of the movie. For example, Harry Potter 1, Harry Potter 2, Harry Potter 3. Okay, and let us consider other movies. Okay, so there are the total 7 movies in my data set and 4 users, and each user are giving some specific rating to that movie out of 5. So let us consider the user A giving an rating 4 to Harry Potter 1, rating 5 to TW movie, then rating 1 for SW1 movie. Okay, while user B is giving the rating 5 to Harry Potter 1, rating 5 to Harry Potter 2, rating 4 for the Harry Potter 3, and the rest of movie he don't like, so he is not giving any rating to them. Okay, so same, the user C providing the rating for the respective movie, TW, SW1, SW2. Okay, and the user D is providing the his own rating for the Harry Potter 2, that is a 3, and the SW3, that is 3. Okay, so this is a rough user data. Now consider the user X and Y with a rating vector Rx and Ry. Okay, so what we have to find out? We have to find out the similarity between the 2 users. So which 2 users we are considering? Let us consider consider the user X and the user Y. So when you considering the user X and user Y, so you have to consider their rating value as a vector. Okay, so how we can represent that vector? Here we are representing that vector as a Rx, for it is indicating the rating values as a user X, and Ry, that is indicating the that is storing the all the rating value of the Y user. Okay, now the next we have to find out the similarity matrix. Okay, so what is the similarity matrix? We have to use the similar function, for example xy. So we have to find out the 2 user similarities. So here we are first we need to find out the similarity matrix, and then capture the imputation that similarity between the A and B is greater than the similarity of A and C. So this is my hypothesis. Okay, so here I am using the hypothesis that the similarity between the user A and B is more as compared to the similarity between the A and the C. What it means is that it means that when the user A watched the movie, for example Harry Potter 1, so you can give the recommendation to the user B that he must watch the movie HP2. Okay, that is Harry Potter 2, or vice versa. So let us consider user B is watching a movie Harry Potter 3, and user A is not watching the Harry Potter 3. So your search engine or your recommendation system will provide the recommendation to the user A is that, hey user A, you can watch the Harry Potter 3 because you may be like this movie. Okay, because your friend, for example user B, is watching now this movie. Okay, so such type of recommendation you can give to this similarity function. Okay, so here I am using the imputation, or you can use the hypothesis that similarity between the user A and B is greater than the similarity between the user A and the C. How you can prove it that? To prove this, there are the two inbuilt functions. So first we are seeing the Jaccard similarity function. So what do you mean by the Jaccard similarity function? The Jaccard similarity function, the formula is that mod of rating of A intersection mod of rating of A intersection of rating of B divided by mod of rating of A union rating of B. So this is called as a Jaccard function. So here we have to find out the similarity between the user A and B. So that's why we are taking all the rating by using the rating vector RA and RB of respect to user A and user B. Okay. So what we are doing here, we are finding out the intersection and the union of rating A and the rating B. Okay. So when you find the intersection of rating A to rating B, so we are getting the 1. Out of 5, we are getting the 1, and similarity between the A and C, we are getting the 2 by 4. Now, let me explain this in detail. So, what do you mean by the 1 by 5 and the 2 by 4 here? So, the 1 by 5, it means that you can see, you can just consider the user A and B here. So, user A and B, if you consider the user A and B, so when the user A, how many values in a vector? 4, 5 and the 1. And when you are considering the user B, so what are the value in a R vector, RB vector? So there is a 5, 5 and the 4. And this is, they are common for the movie Harry Potter 1. Okay, they are common for the movie Harry Potter 1 because they are both are giving the rating for the Harry Potter 1, that is nothing but the user A giving the rating 4 to the Harry Potter 1, and the user B are giving the 5 as a rating to the Harry Potter 1. So that's why it is 1 divided by the 5. As compared to the similarity between the A and C, so just consider the A and the C now. So A is giving the rating 4 to the Harry Potter 1, then 5 to TW1, and 1 to SW1. While user C is giving the rating to TW, that is a 2, and SW1, that is a 4. So the these rating are common for the A and C out of these 4. 1, 2, okay, 1, 2, 3, 4. Okay, so out of these 4, there are only the 2 common movie, they are giving the same, they are giving the rating, that is the TW and the SW1. Okay, so that's why we are considering the 2 by 4. Okay, now, so when you finding out this similarity between the A and B, that is 1 by 5. So when you calculate it 1 by 5, so let me calculate it 1 by 5. What is the answer for 1 by 5? When you calculate this 1 by 5, so it is a 0.2, and when you consider the 2.5, so it is a 0.5. Okay, so 1 by 5 is nothing but 0.2, while 2 by 4 is 0.5. Okay, so it is not satisfy our hypothesis. As our hypothesis, we are in the first slide we are providing that similarity of A and B is greater than the similarity of A and C. Hence, our hypothesis is false. Through this Jaccard similarity, the Jaccard similarity say that no, the similarity between the A and B is less than to the similarity between the A and the C. Why? Because you can find out using this Jaccard formula, and you have proved that the similarity between the A and B is less than the similarity of A and the C. But when you find this manually, so you can find out that A and B are more similar, they have the more similar as compared to the U and C. So this, even though this Jaccard similarity prove that the similarity between the A and B is less than the similarity of A and C, there is another method you can find out this similarity, and that is called as the cosine similarity. Okay. So what do you mean by the cosine similarity? So in the cosine similarity, we have to find out the cos value. Okay. So before we start this cos value, what we have to do, whatever the null value is there, you have to replace that null value with a 0. Okay. So you can see in the data set, rating by A is now 4005100. Okay, and for B it is nothing but the 554000. So replacing all the null value with the 0 1. That is the first task you have to perform in when you are using the cosine similarity. Okay, so when you use the cosine similarity, the similarity between the A and B is equal to cos of RA and the RB. So what is the RA and RB? RA and the RB are the vector of rating given by the user A, and RB is a vector of rating given by the user B. So how we solve this cos RA, RB? So to solve this cos RA and RB, there is a formula, that is a Rx and Ry divided by mod of Rx into Ry. Okay, so this is a simple formula to find out the cosine similarity, and when you implement this cosine similarity, now you are getting a different output. What is that? Now your similarity between the A and B is now 0.38, while a similarity between the A and C is now 0.32. Even though the matching is very there is no large difference between the similarity between A and B and A and C, but even though you can find out the similarity of A and B is greater than the similarity of A and C. Okay, so you can find out using this cosine that similarity between the A and B is greater than the similarity of A and C. Now, how to find out this cosine similarity? To solve this cosine similarity, here you have to use the formula cos Rx and Y. So what is this Rx? Rx is nothing but your vector, rating vector of X and rating vector of Y. So you can see on the right hand side 4 into 5. So what is that 4 and 5? So 4 and 5 is nothing but similarity between the A and B. So A and B are in common when there is a movie HP 1, that is Harry Potter 1. So user A has given the rating 4 and user B are giving the rating 5 for the Harry Potter 1 movie. Okay, so that's why we are giving the 4 into 5. So 4 into 5 divided by the vector of A. So what is the vector of A? 4 whole square, 5 whole square plus 1 whole square multiplied by B. So what is B? 5 whole square plus 5 whole square plus 4 whole square and the rest of the 0. Okay, so is equal to 20 divided by root of 16 plus 25 plus 1 multiplied by 25 plus 25 plus 16. It's nothing but 20 divided by 42 multiplied by root 42 multiplied by root 66. So when you find out the root 42 and the root 66, so it is nothing but the 6.48 and the 8.1. So 20 divided by 52.617. So when you solve this problem, you will get the value 0.38, and this is nothing but this value. So similarity of A and B is nothing but 0.38. So let us consider the second example. In this example, we are using the some utility matrix. Here there are the 4 users named as A, B, C, and D, and the 6 movies. Okay, these are WT1, that is a wrong turn movie, then TM, that is a matrix, and the XM, that is a Spider-Man. And each user are giving their respective rating for the movie wrong turn, the matrix, and the Spider-Man. Okay, so this is a matrix, utility matrix. Now In this example, let us consider A and C. They having a two common rating. You can see the user A and C. The user A and the C having the two common rating for the movie Wrong Turn 1 and the Matrix 1. Okay. So TM1, in the TM1 you can see the user A and the user C are giving the rating 5 and 4, and Wrong Turn, that is a 3 and the 5. So they have the common rating between the for the movie WT1 and the TM1. So let us consider these two users A and C, and then find out the common similarity, cosine similarity between the A and C. So how we can find out the cosine similarity between the A and C? So here is a formula I have to solve. 3 into 5 for the wrong turn. Okay, 3 into 5 plus 5 into 4 for the Terminator 1. So they are having the common rating between the two movies, Wrong Turn 1 and the Terminator 1. So I am considering these two common rating, that is a 3 into 5 plus 5 into 4 divided by the vector, that is a 3 square plus 5 square, because A is giving only the two movies rating, that is the Wrong Turn 1 and the Terminator 1. So 3 square plus 5 square into vector of C, that is a 5 square plus 4 square plus 4 square plus 5 square. So is equal to 15 plus 20 divided by root of 9 plus 25 into root of 25 plus 16 plus 16 plus 25. So it is nothing but 35 divided by root of 34 into root of 82 is equal to 35 divided by 5.83 into 9.055. And this is nothing but 35 divided by 52.80. So you have to find out this. So this is this second cosine similarity between the user A and the C. And you can find out the cosine similarity between the A and C is 0.662, and the cosine similarity between the user A and B is 0.167. So hence the similarity between the A and C is greater as compared to similarity between the A and B, that is 0.16. So here we can say that these two users have more similarity as compared to the A and B. Okay. So this is a conclusion from our result. Now the third type of to find out the similarity, that is called the centered cosine. Okay, the first one is the Jacob similarity, second one is the cosine similarity, and the third type is called the centered cosine similarity. Okay, so how to find out the centered cosine similarity? So to solve the problem of the centered cosine similarity, what we have to do? We have to make the addition of this vector. Okay, so the rating given by the user A, that is a 4, 5 and 1. So what I am doing here, I am adding all these rating, that is a 4 plus 5 plus 1, that is nothing but the 10, and similar for the user B, that is 5 plus 5 plus 4, that is a 14. And how many ratings they are giving? The user A are giving the rating for the 3 movie, that is a 10 by 3. And user B are giving the rating for the 3 movie, that is a 5, 5 and the 4. Okay, so in the centered cosine, we are making the addition of all the rating in the vector divided by the number of rating. Okay, so here user A is giving the 3 rating for the movie HP1, TW and the SW1. And same, the user B are giving the rating to the HP1, HP2 and the HP3. So that's why you can see here on the right hand side, this is a 10 by 3 and the 14 by 3. So this is the first step you have to use in a centroid cosine. You are making the addition of all the rating divided by the number of rating. Okay, so addition of all the rating means A, that is user A giving the rating 4 plus 5 plus 1, that is 10. And how many rating they are giving? It gives the 3 ratings, so that's why divided by the 3. The next task in a centroid cosine is.
सर मेरे को लास्ट वाले स्लाइड में एक डाउट था.
In the second step, what we are doing here? देखो क्या किया है यहाँ पे. Now, in previous step we have find out the mean value, that is 10 divided by 3. So minus this value 4 minus 10 divided by 3. Okay, and then let the find out the answer. Okay, and then you have to find out the cosine similarity again using the formula of cosine similarity, and you can get the answer for cosine similarity between the RA and RB is equal to 0.09, and the cosine similarity between the A and C is equal to minus 0.56. Okay, so hence the centered cosine is also prove that the similarity between the A and B is greater than the similarity between the A and C. Okay, so hence we prove that the similarity between the two users, that is user A and B, is greater than the similarity between the user A and C by the two formula, that is the cosine similarity formula and using the centered cosine similarity formula.